data algorithms. So remember we talked about collection being a group of objects. So we need a way to be able to represent these groups, and that's where collection framework comes in by providing us the set of interfaces for that, and also classes for that. So a Java collection interface provides abstract data types to represent a collection. So I think for these slides, I'll go ahead and share some code for this. And then the Java collections class consists exclusively of static methods that operate or return collections. Or rather, in simple terms, it provides you with various algorithms that can be used to manipulate elements stored in data structures. So let's go on. So we are going to start with the collection interface. In the interface, not the collection without an S, without problem. So the collection interface itself, it's like the root interface. So it kind of gives us the blueprint for all other sub interfaces that can be implemented using the collection framework. So I've attached a list of some very cool documentations, I think, which have simply explained this. And so for this session, we're going to focus on the commonly used sub interfaces. So we're going to look at lists, sets, and maybe queues. So there are more. As you can see, we have maps, we have iterators, but we're going to focus on these main three. We're also going to maybe mention the iterator. So we're going to skip them up for now, and on this link that I've attached on Oracle, you can maybe get a time to have a look at it. All right, so we'll start with the list, which is most common. So the list presents us with a noded collection that will allow us to store and access elements sequentially. So note that it's ordered. So data that's stored in a list is stored in an order. So like you have a list of integers that can be stored in an order of the indices. So like the item at 0, item at 1, and 2, and 4. So let me jump straight forward to the code. Now we can see them in action. All right. So for the list, you are allowed to define a list of anything you want. So in this example, so we are like going to define a list of integers, and then we're going to implement array list. And so a good concept is when we learned about object-oriented programming, you learn about interfaces. So the only way to use interfaces is like to implement them. And the way interfaces are different from classes is that you cannot instantiate one. So for example, if this list was a class, and we can maybe click on it, and we can see the list is a interface here that extends sequenced collections, which in itself extends the collection interface itself. So the collection interface here. So, and if you go back to our list, maybe we want to do this, but we cannot do it. And the ID will conflict because the list is abstract and cannot be instantiated. So this is the same thing what happens in interfaces. So I'm not going to maybe go deep into this because I know you guys in OP session. Okay. All right, let me zoom in the font. Okay. Okay. I don't know how to do that. Let me see. Now that I know how I can do this.
You can try going to settings and select fonts.
Okay, that's fair.
Editor, yeah, should be editor under editor font, yeah, under editor, yeah.
Okay. Yeah, let's increase this. Yeah, is this clear? Is it better? Okay, awesome. So let's go on. So you can see the list here. We are going to create a list of the CDs, and then we're going to use an array list. So back to my slides here. So back to my slides. You can see that some of the common ways we can implement a list includes using an array list, a linked list, a stack, or a vector. But in our example, we'll start with the array list. So we're going to create a list of cities here, and then we just implement it using an array list. And so it allows us to have a few of the methods that are defined in the collection framework, such as add, get, basically the base methods. So if we go to the collection, let me go to the collection here. You can notice it has some of these abstract methods that are not implemented. So for example, size, to array, and also add, all these methods. And so the list also defines them, and then the array list is where these methods have been implemented. So collection framework heavily works hand in hand with like OOP. So it's important to like understand the concepts of OOP, but you also try to understand the collection framework. Okay, so you can see, for example, these are just the implementations of this method, of these methods, and they are done here in the release class. But if you go to maybe the collections, you just see there are no implementations. Okay, so let's continue. So this is just a simple list. We can be able to like add elements into it, and we can also remove, and we can maybe like get elements given indexes, and yeah. So that's much of it of the array list. So let's keep these collections. We are going to come back to this, and also one may wonder, why would you want to use an array list instead of using the normal array? So I think one of the advantages of using the array list is we can increase the size of this array, and we can also decrease the size, and also like we can add elements into it without like having to create a new copy. So for the native Java list, for example, this course that prepared for us. So if you want to have maybe an array of integers from 1 to 5, so this size is fixed, like 1, 2, 3, 4, there are just 5 elements here. And we cannot come and try to add an element here. So like there's literally no way for us to do that. The only way for us would be to create a new array, which would now maybe, for example, allow 6 items. And then we're going to transfer all the items in the original one, and then in the last slot, or rather the last index, we can add that element. But you can see how the array list conveniently provides us with this functionality. Okay, so, and we talked about how there are like many ways in which you can implement your list. So one of the ways we have looked at the array list, the other is just a linked list. Then maybe you can just add items to that linked list. Then you can sort of just try to print your linked list, and you can see your items. Now, one more thing is a clear advantage of using like the list interface rather instead of using like an array list. For example, one might wonder, why didn't we just declare an array, or rather declare our cities with the array list? It's now gets to be like strongly tied to an array list, and we cannot do much about it without like changing the data type. So for example, let's say we wanted to switch our implementation to a linked list. You see, we're going to have an error here because we cannot do that, right? But the moment we like use the list, which is like the parent interface here, we are allowed to just like convert our implementation just as simple as this by just creating a new linked list from the existing array list. Okay. Any questions so far? Just if you can just raise your hand and interact. Okay, but as we go on, we talked about collections with the S, which I said we can denote difference. So collections literally presents us with a set of methods like utility classes, not classes per se, utility methods that will operate on the collections. So let's say, for example, you want to sort values in your list. For example, we want to sort these cities here. So maybe if we could like check, we can see the current order. Like this is the current order. New York is the first one. And then the moment we like do the sort, and then we print the cities, you can see they have been sorted. So sort is a static method that is provided as part of the collections class. And so if you go to the collections class, you can see all the different methods here. So you can see like the sort method here. You can see like the binary search implementation that has been done here, and literally very many useful utility methods you might want to use. For example, reversing the elements in that list. All this is provided. Going back to our list, we have an implementation here that I had highlighted as we start when we say that the collection is a root. We remember we noted an iterator. So this one simply just allows us to like go through each items of the list we have created. So like for example, we may want to like go access an item and we don't know the index. We want to like go through all the items and try to get an item. We could create an instance of the iterator using our list. So for example, tasks was our list here. So we could create a list iterator instance using the tasks, and then we could access elements using the next. And then we have a number of methods which are provided by the list iterator. So you can see we have like has next, next, as previous, all these useful methods you might need. So a very cool example here I had was like let's say you need to like implement a binary search. You could just use the one this utility class provided by the collections class. So and just it does as you expect. It's going to find the element at the given index. Yeah. Okay, so that's much it on the list. That was the first sub-interface I wanted us to discuss. And then the next one will be set. Okay, so in terms of the set, we have a set here. So the difference with set and list is the set cannot contain duplicates. So we have instances where you want to have a list of items, but you don't want duplicates in them. So like let's say what you want to maintain a list of index numbers for each one. So you know that only one person can have a single index number. So you may not want duplicates. So that's where the set comes in. And so the set is implemented differently. In one of the ways in which a set is implemented is using a hash set. Others linked hash set and unset entry set. But we're only going to like have a look at the hash set. So this is how you like create a set. You can create a set and use the hash set. And so you can add items to your set as much as you want. And then one more thing I actually forgot. A set provides the features of mathematical set in Java. So in like what was that topic? There was this topic called discrete maths. So where we had these sort of functions like unions and sets. So unions and intersections. So for example, you may want to have all elements in a set A. You may want to pull them in set 2. So you can use the operations that are provided by set. So for example, this add-on will do a union. So it adds all elements in the collection if they aren't already present and in the both collections. So we have others. Like maybe you want to do an intersection, we have methods for that. I think it's written all. Yeah. So what else? And then remember the iterator. So for example, you may want to like go through each item in the set. You can just use the iterator utility that we learned. And so that's it about sets. What else? Now then we are going to check the other implementation, which is like queue. So the queue provides us with the functionality of a queue. I don't know whether that's a good definition, but like queue, like line, like that order. And so in queues, the elements are stored and accessed in first in, first out. So like the first person, think of it as like a bank queue. The first person who comes is the first person who serves, they leave. So first in, first out. That's like the basic implementation. However, this can also be extended to work with like other implementation, like first in, last out, and so on. And if you go to the code example here, I'll try to create an example of our queue. So here's a queue. So in the queue, this is how we implement queues. So we can use a linked list. Actually, I think they prefer linked list because it always allows us to keep like we know who's next and who's previous. So if we implement our queue using a linked list, we can be able to like add items to the queue, and also we can be able to like check what's on top of the queue. So for example, here we could add numbers to our queue, and let's say we want to find the number that's on top of the queue. We could check that. We could do that. So let me do that. Let me show you quickly. Yeah. So for example, you can see this is our queue. The order is like 0, 1, 2. The numbers are like 1, 2, 3. The way we added them, and maybe we want to get the number that's on top of the queue. We could see the access number here, which is the first item of the queue, and all these other methods are easily provided by the queue implementation per se. So we could remove the numbers. We could like go to we could like view the numbers at the end. We could remove this poll. Normally just removes the number that's on the top, the first number, the one that we picked here. So if you can check, you can see that our queue no longer has the first two items. And so if we go to like these implementations, you can see the methods here, the queue, the poll, the remove, and yeah. So what else? That's what I wanted us to cover today. And so exactly why the need for the collections. So we did like go through the collections, but the collection class, which is part of the Java collections framework. So this one like just provides us with those levels. And remember, I've spoken about it, and they operate on collections. So if you look at an example, for example, in our list example, if we want to like perform this sample, perform a binary search, we call the static methods like the binary search, and then we pass our list which we created here. And so like it's like a wrapper, like it does its computation by wrapping over our existing collection class. So for example, the sorting thing, like we have to like pass to it this object, as you can see. So yeah, so what it's pending. Yeah, so what's more, I actually try to avoid using ChatGPT in this session, but I saw that they have a very good description of what the